We are going to see one more problem in the unit third, that is how to find out the temperature force vector in the constant strain triangular element. That's what we are going to study in this problem. The temperature force vector problem is formula is given. F is equivalent to temperature force vector is equal to B transpose D E naught area A into T. This is initial strain. This is stress strain relationship matrix, strain displacement matrix, and thickness area. This formula we have to find out B D E naught A T. Then we have to substitute in this and find out the temperature force vector. We'll go into this problem. Calculate the element stiffness matrix and the temperature force vector of the plane stress. So now we got plane stress. Plane stress shown in the figure. The element experiences a 20 degree initial increase in temperature. Assume coefficient of thermal expansion 6 into 10 to the power of minus 6 degree Celsius. Young's modulus is 2 into 10 to the power of 5 Newton per millimeter square. Poisson pressure nu is equivalent to 0.25 and thickness is equal to 5 mm. And this is the constant triangular element. They are x1, y1, x2, y2, x3, y3. 1, 2, 3. The node should be in such a way. 1, 2, 3. So the element, and I have written x1, y1, you see 0, 0, x2, y2, 2, 0, and x3, 1, and 1, 3. So every coordinates I have written, and the given data is written, and this is 10 degrees Celsius. This is 10 degrees Celsius. Coefficient is 6 into 10 to the power of minus 6 degree Celsius. So we got this. Now we will find, and they asked you to find both element stiffness matrix and temperature force matrix. So whatever it is, the first thing is that we have to find out the area. So the area, this is the area, and it is x1, x2, x3, y1, y2, y3. So we know the coordinates from the triangle, it is given. So I am substituting this coordinate value and I am finding the determinants of that, and I am finding the determinants 6 minus 0 and 1, we have to keep it up, and 6 minus 0, you know how to find it out. So this is should be given in a bracket. So area is equal to 3 millimeter square. Now according to the stiffness matrix, B transpose D B A into T. So I am going to find anything, we have to find it out. This is not in the order. You find D or B, but in order you multiply. That is the important thing. So B we know 1 by 2 by Q1 0, Q2 0, Q3 0, 0 R1, 0 R2, 0 R3, R1 Q1, R2 Q2, R3 Q3. Say this I have this Q1 is equal to, and I already explained this is, look here, this problem 1, 2, 3. So now this is the Q1, I have to find it out. So how to memorize this? So see here 1. So Q1, so this you keep a hand like this. Now 2, 3, so y2 minus y3. Now if you want to find out Q2, see u3 minus u1, just keep this 2 in this way. You just forget the 2, and 3 and 1 are u3 minus u1. Then if you want to find out the 3, just close this u3. Then remaining is u1 minus u2. So in this way you find out the memorize. This is some way of logic to find out the the Q1, Q2, Q3 values. So now R1, how can I find it out? X3 minus, see, exactly opposite. Here y2 minus y3, here x3 minus x2. Y3 minus, once you know how to find out this, just put the reverse of that. That is R1, R2, R3. So this value should be substituted here. So I have substituted this value. And area I have substituted 3. So I got this value. I have divided this, I got 0. Now I have substituted, this is plane stress problem. So this is the formula we have to take for stress strain relationship. So stress strain relationship D has holds here this formula for plane stress condition. So this is the formula. Mu it is Poisson ratio. Everything is given. So you what? Substitute these values and you got this value. The D matrix value, you got it. Now I got this value. So now I am dividing simplifications. I got this. So I got D and B. So we know B transpose. We have to find out the B transpose. The B values is this one. Write the transpose of this matrix. This is the right. So we know we got B transpose, B and D. Multiply these three. This way. B transpose, D, B. B transpose and D first. Then I have made this. This and this should be multiplied. This and this should be multiplied. Put outside that. So this is what I do. So this and this are multiplied. You know that this into this, this into this, this into this, and you know that you find it out. You get this, you get this. So now we have to find it out. B transpose D. B transpose D is this one, this value, and B is this value. So both I have B transpose D. B transpose D is this value. B transpose D is this value and multiplied by B matrix. I got this. Now this completely I got this. Now I have to multiply A into T. So now I 3 into 5. This is A into here. I got stiffness matrix. So that's all for the stiffness matrix. I got this. So every step it is displacement, strain displacement matrix, first area strain displacement matrix or stress strain relationship matrix, then find the B transpose, then multiply in order as like in the formula, you will get the stiffness matrix. Now for plane stress condition, we have to find out the temperature force vector. The temperature force vector formula is B transpose D E naught A into T. So we have to find out the initial strain. The initial strain is formula is given by alpha thermal coefficient of extended temperature difference. So this is 10 and 10. So this is 10. Substitute this value is alpha. It is given in the book. Delta T is given in the book. So you got this value. So now you know B transpose, you know D, and you know E naught, and you know. So multiply in the order. B transpose D, E naught, A into T. See, that's what I have done. B transpose D, B transpose D already we know. So this into E naught. So this value. So from this value you got this. So now you are getting this value. Multiply this and this. Take this and this multiply and you got this. And this and this I multiplied, I got this. So this is the value. So temperature force vector is we got 121.5, 40.05, 121.505. These are all the forces due to arised. This is arised due to the temperature effects in the element. So here only thing we have to consider, if the problem the stiffness matrix is asked, you do it. Otherwise straight away apply this formula. Find B, then find B transpose, then D, then this one and this. No need of finding out the global stiffness matrix. If they are asked global stiffness matrix and temperature, they can ask stresses also here. You can find the stresses over here, principal stresses. So they may ask according to the questions you answer. Thank you.